Okay, we're doing permutations using nPr. So in permutations, we're looking at groups of objects where the order that we select those objects in makes a difference. So for example, when you pick the lottery numbers, it doesn't make any difference what order you select the numbers in. So that's not a permutation. Just so long as you've got all the numbers, that's all that matters. But something like who wins a running race, for example, the order that the runners come in is of importance, so that becomes a permutation. So we want to pick groups of objects. The order that we pick them in is important. So if we look at a simple example, say we have groups of 3 letters, so say A, B and C. If we want to make groups of letters, we have a few ways of doing it. For the first letter, we have 3 options, an A, a B or a C. And we pick another letter, but we've already picked one, so we've got 2 left. So there's 2 options for the second letter. And for the last letter, there's only 1 left, so 3 times 2 times 1. 3 twos are 1, 3 times 2 times 1 is 6 different ways that we can arrange those letters. Let's think of a harder example. Let's assume we've got 10 letters. Right, in 10 letters. Now, with this example up above, we had 3 times 2 times 1, which was 3 factorial. When we pick the groups of 10 letters, we only want groups of 3. We can't just use 10 factorial because we're not arranging all the 10 letters. We're only arranging 3 of them. So, for our first letter, we have 10 options. It's an AND problem, so times the second one. We've got 9 options for the second letter and 8 options for the last letter. All right? 10 times 9 times 8 is 720 ways to arrange our 10 letters into groups of 3, where the order of the letters is important. Now, let's look at this a slightly different way. If we had 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1 divided by 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, this calculation, that'll cross out, they'll cross out, they'll cross out, and so on. They all cancel out. I'm left with my answer to my original problem. Alright, so another way of actually writing this is 10 factorial divided by 7 factorial. Alright, another way of thinking about this, 10 factorial divided by 10 minus 3 factorial. Okay, this forms the basis of nPr. N is the number of objects that we have. R is our group size. Okay? So what we effectively have in this here is a slightly different, right, slightly differently. What we effectively have is nPr equals n factorial over n minus r factorial. Okay? And that's just a technical way of writing that there. Okay? My n and my r works out just like this. Okay? Alright, let's have a look at some examples. A new sheet of paper. Alright, let's have a look at an example, say, in the book. Oh, excuse me. Worked example 11. Now, this is a straightforward one. Calculate 7p3 3. Well, it's quite straightforward when we answer it. 7p3 equals 7 factorial over 7 minus 3 factorial, because that's the formula that I used just a minute ago. So what we're effectively doing here is we're having groups of 3. We've got 7 objects to choose from. Okay? 7 factorial over 4 factorial. 7 minus 3 is 4. If we work that out, 5040 is what 7 factorial is. 4 factorial is 24. 5040 divided by 24, 210. So in my group of 7 objects, I'm arranging them in groups of 3. There's 210 ways of doing it. Okay, let's have a look at another example. This one's from the book again, worked example 12. Right, so the question says, only the 3 fastest cars in a rally of 10 competitors will compete in the World Championships. How many different arrangements of the 3 fastest rally cars are possible? So let me say that a slightly different way. We've got 10 different cars. We want groups of 3 of the fastest. So from our 10 that we choose from, we want groups of 3. So this is our number that we have. This becomes R. So my calculation is 10p3. Now you can put that straight into your calculator by using the buttons on your calculator. Otherwise, 10 factorial over 10 minus 3 factorial. Plugging that into your calculator, you'll end up with, there's 720 different ways that we can arrange those cars. Alright, let's have a look at the next one. Worked example 13. How many different numbers greater than 1000 can be formed using the digits 4, 5, 6, 7, 8 and 9 if a digit cannot be used more than once? So we can use 4, 5, 6, 7, 8, 9. Okay. Now we want numbers greater than 1000. That's going to affect what we do. So let's have a think. What is n? N is the number of letters we have to choose from. 1, 2, 3, 4, 5, 6. Okay. Now R, R is going to change. We want numbers bigger than 1000. So if I have a 4-digit number, the smallest 4-digit number I can have would be 4,567. I could have a 5-digit number or a 6-digit number. So R is going to be groups of 4 numbers, groups of 5 numbers, and groups of 6 numbers. So write that out using nPr format. We're going to have 6p4 for the 4-digit numbers, plus 6p5 for the 5-digit numbers, plus 6p6. So a 4-digit number could be 4,567, it could be 9,876, doesn't really matter. Groups of 4 numbers, groups of 5 numbers, groups of 6 numbers, and I'm choosing from 6. Now you can plug this into a calculator. 6p4 is 360, 6p5 is 720, and 6p6 is 720. Add those numbers together. There are 1,800 numbers greater than 1000 that can be formed from those digits. 1,800. Okay, let's look at worked example 14. Last one. Okay, worked example 14. Captain and vice captain are to be chosen from a group consisting of 10 cricket players. Okay, so let's have a think about this. We've got 10 cricket players. What's that going to tell you? N is 10. From the remaining 8 players that are left, 3 will be selected to be the wicket keeper, spin bowler and fast bowler. Okay, so we've got 2 different questions here. First thing we want to think about is, we've got 10 cricket players, we're going to choose a captain and a vice captain. Alright, so captain plus a vice captain. There's 2 positions there. R is 2. So, first part of this question, we have 10p2. Right. Once we've done that, now we've got to pick our wicketkeeper, spin bowler and fast bowler. So, we've already taken 2 players out. N is now 8, because out of my 10 players I've got 8 left. I want a group of how many players? I want 3, because I've got my 3 positions. Wicketkeeper, spin bowler, fast bowler. So to answer this one, 8p2. Now, how many different ways can all this go together? Righto. 10p2 and 8p2. I need both of these events to happen. Okay. They've got to happen together, so it's an AND event. It's not an OR event. I need that to happen, and I need this to happen. Two captains and vice captains. Oops, I'm mistake. 3. One mistake. I made a mistake there. 3 other players. When we work this out, 10p2 is 90. 8p3 is 336. Multiply them together. 30,240 ways of selecting my captain, vice captain, my wicketkeeper, spin bowler and fast bowler from all of those players. Okay, exercise 12D is your next activity.